Hello everyone. Today we are going to discuss about the Newton's laws of motion. Students, in my previous video I explained about the Galileo's experiment. In that experiment he discussed about the natural state of a particle. On the basis of that observation, or we can say that his work has explored by the great scientist Sir Isaac Newton. Means on the basis of his work, Sir Isaac Newton has deduced three laws of motion. That three laws of motion are known as the first laws of motion, the second laws of motion, and the third laws of motion. According to Newton's first law of motion, a body at rest will remain at rest and a body in motion will remain in uniform motion unless an unbalanced force acts on it to change its state of rest or uniform motion. Okay, so from the above experiment, we can deduce this experiment, we can explain this experiment in two ways. That suppose if a body is in the position of the rest, then it will remain in the position of the rest unless an external unbalanced force acts on it to change its state of motion. To change its state of rest. And number two, the body will, if the body is in motion, then it will remain in motion still any external force changes its state of motion. Okay. So, from this Newton's first law of motion, we get the definition of force. Means this Newton's first law of motion leads to the definition of the force. Further, this Newton's first law of motion is also called Galileo's law of inertia. Okay, and according to these laws of inertia, the tendency of a body to oppose any change in its state of rest or uniform motion is called the inertia of the body. So this inertia of the body, we can define this inertia of body in two ways. First, the inertia of rest, and another is the inertia of motion. And the third, that is the inertia of direction. So let we discuss one by one. Now let we come across some of the examples of inertia of rest. And there is a window of glass. It is made up of glass, and this window pane is struck by a bullet, and you will observe that it is making just a small hole. The total window is not breaking. So what is the reason? Let me explain. See, the window pane was in the position of the rest. Initially it was in the position of the rest, and when this bullet strike on it, the bullet is having a very high speed. So within that contact of time, means within that very small contact of time, the bullet it is not possible to shake the whole window. And since the window is having a tendency to remain in the position of the rest, so it will remain in the position of the rest. And only that portion in which the bullet is in contact, that portion it will make a hole. Okay. Now next we come to the next example. Now you can see there is a pile of coins and a striker hitting it. So when this striker hit this pile of coins, you will see that only that coin which is getting strike, that only displaced, but other coins again arranged their previous position. So what is the reason here? So here also the reason is the same. Means when we are striking the pile, the which is pointed, means in that pile in which we have just striked, only that that coin became the position of the motion, because all others are still in the position of the rest. And since this striker is coming with a high speed, so it will only displace only that striker on which it is hitting, and on that coins on which it is hitting, and the others will remain in the previous position. So all these were the examples of the inertia of rest. And in our next video we will discuss about the inertia of motion. Okay.